A problem with a particular problem from the homework, so I wanted to go through it here. And the problem looks something like this. Now, the numbers you have will be different than the ones I have. I'm doing that intentionally so that you still have to go through the math yourself. But it's a network where we have two devices hooked up in series on one side of the network. Then parallel to that, we have another two devices, device 3 and 4, hooked up in series on the other side of the parallel circuit. And the probability that each of these work, the probability that one works, is equal to the probability that device 2 works, which is equal to the probability that device 3 works, and is equal to the probability that device 4 works. And I'm going to put in a number here that the randomized system won't use. I'm going to say that probability is 0.35. Now, a concept that we talked about briefly is the idea of a complement. So the complement of working would be not working. So the probability that one does not work is going to equal the probability that 2, and I'm just going to do 2, 3, 4 not work. Probability that each of them does not work is the complement. The complement of 0.35 would be 1 minus 0.35, or 0.65. So the probability that each of them individually would not work then would be 0.65. Now I realize this is a very low probability of working and a very high probability of not working, but that's the way this problem is set up to go. So then as we go down through the problems here, the first step of the problem, part A, is saying the 1-2 subsystem only works if both components work. What is the probability that this happens? So it's the probability that the 1/2 subsystem works. So that 1/2 subsystem, that's this part up here, that branch. So that branch needs to work. The probability that that branch will work is simply the probability that one works, since they're independent of each other, times the probability that 2 works. They both have to happen. So for here, that'd be 0.35 times 0.35, which gives us, what is that? Did not open my calculator here. Let me get that open. I believe it's 0.1225, but we'll double check it on the calculator. There it comes. So 0.35 times 0.35. It is 0.1225. So that is the probability that that top subsystem works. The 1-2 branch of that subsystem works, 0.1225. Now the second question, part B, is asking what is the probability that the 1-2 subsystem does not work. Well, again, this is just the complement of it working. So the probability that it works is 0.1225. The probability that it does not work is 1 minus 0.1225, giving us 0.8775. That is the probability that it does not work. So then part C, I should say, the third part. What is the probability that the 3-4 subsystem does not work? Well, since the 3-4 subsystem is identical to the 1-2 subsystem, they're in, the 1-2 is in series, both with a probability of 0.35. The 3-4 is in series, both with a probability of 0.35. So the probability of the 3-4 subsystem working is the same as the probability of the 1-2 subsystem working, and the probability of them not working is the same. So the probability that that would not work is also 0.8775. That's not part C, that's actually just the second part of part B. So part B had 2 questions there. Now we'll move on to part C. The system won't work if both systems fail. So what we're looking for here is what is the probability that both the 1-2 and the 3-4 subsystems fail. So both of them will not work. So again, they're independent. So this is just the probability of the 1-2 subsystem not working. I'm just going to put 1-2 not work, times the probability that the 3-4 subsystem does not work. So that's just going to be the 0.8775 times 0.8775. So 0.8775 times 0.8775, giving us 0.7700 if we're rounding to 4 decimal places. So that's the probability that it will not work. The second part of part C then is, what's the probability that it will work? This is the probability that the whole system works. And just like up above, this is the complement of it not working. So that's just 1 minus the 0.7700. So that's 0.22, 2300 I should put in here. That's the probability that the whole system will work. That's the purpose of these redundant systems like this, these parallel systems, is the probability of the whole system working is much higher than the probability of a single branch working. You'll see up here the probability of a single branch working was just 0.11225. But the probability that the whole system works is much larger than that, 0.2300. Because of the redundancy, that either branch can function to make this work. See, my background is off. It's causing me to look really strange on camera and fade in and out. I apologize if that's distracting. So then next, it wants us to do kind of a what if thing. And what it's asking us to do here is now if we add, so keeping the 1-2 subsystem and the 3-4 subsystem, but then adding a third branch, a 5-6 subsystem. So there are 3 branches, and now each of these branches has that same probability of working. So the probability that a branch works is 0.1225. Probability that a branch doesn't work, put not work, is the 0.8775. So then for part D, what it's asking, how would the probability of the system working change? So if we've added this, so this is what the probability that the new system works. And to do this, we have to remember the process we went through up above. First, we have to find the probability that the system does not work. So the probability that the system does not work, remember, all three have to not work. That's the probability of the 1, 2, and the 3, 4, and the 5, 6 all not work. If any one of the subsystems works, the whole system then works. So this is just the probability of the 1, 2 working. Sorry, not working, I should say. Times the probability that the 3, 4 does not work. Times the probability that the 5, 6 does not work. So that probability is 0.8775 for each of those. So it's 0.8775 times 0.8775 times 0.8775, or I'm going to do a shortcut on the calculator here. It's just 0.8775 to the power of 3, so I don't have to type it in 3 times. 0.6757. That's the probability that it's going to not work. So the probability that it will work is the complement of that again. So 1 minus 0.6757 is going to be 0.3243. That's the new probability that it'll work. Notice how much that increases. And that would be the second part of the question D there, is it definitely increases the probability of working by adding that third branch. Part E is asking us to go back and redo the whole thing. But now instead of adding a third branch, we go back to 2 branches, only now each branch has 3 units on it. So the probability of the 1, 2, 3 subsystem working, I should put down working there just so I know, is going to be the 0.35 times 0.35 times 0.35. Where does that come from? Well, that's the probability that 1 works times the probability that 2 works times the probability that 3 works. Again, each of them, the probability that each of them working is still that 0.35 from above. So I multiply that out, 0.35. Again, I'm just going to do the power of 3 so I don't have to type that in. So I get 0.0429, we'll round that to. The 0.0429 is that probability that it works. So then the probability that it does not work, now remember, that's the same as the probability that the 4, 5, 6 system will work. It's going to be the same probability. So then the probability that each of them does not work again is the complement of that. So 1 minus 0.0429, giving us 0.9571 is the probability that a single branch will not work. And of course, that is the same as the probability of the 4, 5, 6 one not working, because they're identical. So the probability then that the whole system does not work is the probability that the 1, 2, 3 does not work, times the probability that the 4, 5, 6 does not work. So that's going to be the 0.9571 times 0.9571, giving us 0.9571 times 0.5971, so I'm just going to square it, 0.9160. And so then the probability that it works again, it's a complement. It's if it doesn't, if this is the probability that it doesn't work, the probability that it will work is 1 minus the probability that it doesn't work. So that is 0.0840. It looks like we're going to go for. That is the probability that it would work. So you can see by adding that third device into each branch, it definitely reduces or decreases the probability of the whole system working. Okay, so obviously the numbers you have will change because you're given a different probability of each single device working. Most of you are given either 0.2 or 0.3 or 0.4, but in all cases it should be that all of them have the same probability of working. The calculation is the same, you just have to put in the steps that we did here. If you have any questions, please let me know. Hopefully this helps you out.